Greetings children. Today we will discuss about the inverse trigonometric functions. Children, you already know about the trigonometric functions. Their domain and range also you know. The graphs of all 6 trigonometric ratios you know. Now, if you know these things, then I will tell you something. Function, trigonometric functions you know. Suppose I am taking the function y is equal to sine theta. Then this is the function. If you give its input, say theta is equal to 30 degree or pi by 6 radian, then what happen? You will get its value 1 by 2. Suppose you are giving the value theta is 150 degree or 5 pi by 6, then what happen? Again output is 1 by 2. So this is the function. The input is known as the domain and output is known as the range. So you know trigonometric functions for sine theta. Suppose the input is all real numbers and output you will get from -1 to 1. That is known as the range. So you know about the trigonometric functions, their domain and range. Now inverse trigonometric functions. Inverse of any function will exist only when function is bijective. What do you mean by bijective? So whatever the input, their output, okay, input and output. Input we called as a domain and output we called as the range. Corresponding value of each input, there is a corresponding value of output. It means different values of input, output should be the different. If two different values have same output, that type function is not bijective. If function is not bijective, the inverse will not exist. Say in this case, if you take inverse function, say sine inverse x. Now value of x from -1 to 1 we can take and output you will get. Suppose x you are taking half, then what is the output here? Either 30 degree or 150 degree. There is a confusion is there. So this type functions in which inverse will not exist. So first of all, we have to restrict their domains so that this function becomes bijective. To make it the function bijective, then only we can find it inverse. So in the inverse functions, this is very important, their domain and range. For this function, if we restrict it their domain, say we are taking now the domain as -pi by 2 to +pi by 2 radian. That is the input only. It means -90 degree to 90 degree. Now you can check. If you are taking these values, then their output will be different values have different outputs will give you. So it is necessary function should be bijective and define their range also. So now if we restrict our domains, say -pi by 2 +pi by 2, then sine inverse x. So its domain now becomes -half to +1 and range becomes -90 degree to +90 degree or in radian -pi by 2 to +pi by 2. So now sine inverse x is defined. Also you can remember the children, the graph of sine inverse x, you will get mirror image of the function sine theta. If you draw the graph of y is equal to sine x and then find its mirror image, you will get about the line y is equal to x. Then you will get graph of sine inverse x. So you know this type graph you will get of sine x. Its value lies maximum value of sine x +1, minimum value is -1. That is a graph of sine x. Now inverse function. If you draw a line y is equal to x and its mirror image about this line. So this graph will come this side and this graph will come this side of this. So graph of y is equal to sine inverse x, you will get on this like this one. Here maximum value plus 1, minimum value minus 1. These are the value pi by 2, pi, 3 pi by 2, minus pi by 2, like this way. You know children, this graph from minus pi by 2 to plus pi by 2, this graph, this is known as the principal branch. In this graph you can see the function is bijective actually. So we will take principal branch is this, and other branches we can take pi by 2 to 3 pi by 2, then 3 pi by 2 to 5 pi by 2. Same way negative side also, minus pi by 2 to minus 3 pi by 2. These are the other branches. In the question, if they mention the particular branch, then you have to use that one. If they not mention anything, then we have to take always be the principal branch. So in the module, I have given that each function's domain and range. So children, you should remember the domain and range of each function. There are 6 inverse trigonometric functions we are taking. We have given their graphs also. You have to study that one from your modules. Now we will take few examples. Children, see in this example, we have to evaluate the value of tan inverse 10 pi by 6. Now you can see pi by 6 value lies between minus pi by 2 to plus pi by 2. So value of tan inverse of 10 pi by 6, you can say its value is pi by 6. Condition is here, this value pi by 6 should be lies between minus pi by 2 to plus pi by 2. Now we have to find out the value of tan inverse of 10 minus 6. But now here see, minus 6 does not lie in the interval minus pi by 2 plus pi by 2. So its value we can't write as a minus 6. So this identity we are using here, tan inverse of tan theta will be theta only when theta belongs to minus pi by 2 to plus pi by 2. Now first of all, convert this value should be in that interval. So we can say, see children, tan 2 pi minus 6. Tan 2 pi minus theta is minus tan theta, or tan minus tan theta we can say. So in place of tan minus 6, I can write tan 2 pi minus 6. So this value becomes tan inverse of tan 2 pi minus 6. Now you can check children, 2 pi minus 6 value lies in the interval minus pi by 2 to plus pi by 2. So now we can say its value will be 2 pi minus 6. One more method. Do you remember the graph of tan inverse of tan x? This graph we have given in the module. You can see the value of tan inverse of tan x. This will be x when x lies between minus pi by 2 to plus pi by 2. This is a line y is equal to pi by 2. Dotted because values will not touch this. And this is the line y is equal to minus pi by 2. Minus pi by 2, and this is plus pi by 2. Here 0. Y is equal to tan inverse of tan x. Its graph when interval is minus pi by 2 to plus pi by 2. In that range, its value becomes x. So you will get this type graph. Okay. Now, when we go beyond the pi by 2, then its graph will be this one. Change it. You will get y is equal to x minus pi. This graph you will get. This graph y is equal to x. And when you go beyond the 3 pi by 2, then its graph becomes y is equal to x minus 2 pi. Same type graph you will get in the negative direction also. This type graph you will get. Its equation becomes y is equal to x plus pi. Its equation becomes y is equal to x plus 2 pi, and this equation becomes y is equal to x plus 3 pi. This is the graph. From the graph also you can find directly the value of tan inverse of 10 minus 6. See the position of minus 6 on the x-axis. That is your x-axis and y-axis. So on the x-axis, minus 6 will be somewhere here. This is a position of minus 6. Now corresponding value you will get from here. So how much is value? When you put in place of x, minus 6. So what is the value of y? Minus 6 plus 2 pi. That is, y is tan inverse of 10 minus 6. So its value will be, in place of x put minus 6 plus 2 pi. That is the value of tan inverse of 10 minus 6. You can find directly from the graph also. So you have to study about these graphs, tan inverse of tan x, sin inverse of sin x, cos inverse of cos x, and opposite also. That is tan of tan inverse x, sin of sin inverse x. These graphs are given in the modules. Study them. Children, see in this example, if 2 tan inverse x plus sin inverse 2x upon 1 plus x square is independent of x, then in what range value of x will lie? So if you remember the identities, in the module we have given sin inverse 2x upon 1 plus x square. If x is greater than 1, then its value will be pi minus 2 times tan inverse x. If, then its value will be minus pi plus 2 tan inverse x. And if mod of x is less than or equal to 1, then its value is 2 tan inverse x. That is the value of sin inverse 2x upon 1 plus x square. Depends the value of x lies in what range. You want independent of x. So it means 2 tan inverse x plus which value we have to adopt from here so that this will be cancelled. If you take the first one, that is pi minus 2 tan inverse x. So you will get pi. It means x should be greater than 1. So x belongs to 1 to infinity. That is the correct answer. Now if you take the second one, so in this case value of sin inverse 2x upon 1 plus x square is minus pi. So we are taking minus pi minus 2 times tan inverse x. Again this will be cancelled, you will get minus pi. Again independent of x. It means x belongs to minus infinity to minus 1 also. If you take the third one, so 2 tan inverse x plus 2 tan inverse x, it becomes 4 tan inverse x. It means x should not belong to this one. So what is the correct answer here? X belongs to 1 to infinity and minus infinity to minus 1. Now they have given the closed interval. You can check. If you take x is equal to 1, how much you are getting here? So 2 tan inverse x plus sin inverse 2x upon 1 plus x square. If you take x is equal to 1 here and here, then put x is equal to 1 here, it becomes 2 tan inverse 1, that is tan inverse 1 is pi by 4. Put x is equal to 1, it becomes 2 upon 2 sin inverse 1, that is pi by 2. So again it is pi, independent of x. So x belongs to 1 also. So we can take x belongs to closed interval, then its value will be pi. Same way at minus 1 you can check. So these two answers are the correct answer, plus 1 to infinity and minus infinity to minus 1. Minus 1, at minus 1 also you can check. And again you will get independent of x. So correct answer is there, two correct answers. Minus infinity to minus 1 and 1 to infinity. Then you will get independent of x. Next example children. If x lies between 0 and 1, then we have to find out the value of this expression. Expression is root 1 plus x square. into x of cot inverse x plus sine of cot inverse x whole square of this minus 1 and whole square root of this. Let us do. First of all, simplify this curly bracket. Root 1 plus x square as it is, x cos of cot inverse x. Now, first of all, try to simplify these two. Sine of cot inverse x. Now, children, we have to simplify this portion and this portion first of all. Let us suppose cot inverse x is equal to theta. Then what is the value of x? Cot theta. So cot theta we can say base upon perpendicular. Base is x, perpendicular is 1. Now we have to find out the cos theta and sin theta. We have taken this as a theta. So it becomes x. Cot inverse x becomes theta. Sin theta whole square minus 1 whole square root multiplied by root 1 plus x square. Now children, cot theta is x. Then you can find the value of cos theta and sin theta. Cos theta will be x upon root 1 plus x square and sin theta will be 1 upon root 1 plus x square. These two values I am substituting here. So root 1 plus x square multiplied by x. Cos theta is x upon root 1 plus x square, so it becomes x square. Sin theta is 1 upon root 1 plus x square and whole square minus 1 and whole square root. Children, simplify this curly bracket. If you take LCM, it becomes root 1 plus x square whole square minus 1 and square root of this root 1 plus x square. If you do squaring of this, it becomes 1 plus x square minus 1. Its value is only x square and root 1 plus x square as it is. Now square root of x square, it becomes only x. So x multiplied by root 1 plus x square. That is the simplest form of this expression. So children, now you can simplify using the inverse trigonometric identities. This identity we have used here. So using the identities, you can simplify the given expression in simplest form. So now you can check which is your correct answer. X root 1 plus x square, C is the correct option. Again, in this example, we have to use the inverse trigonometric functions ki identities and reduce in the simplest form. Here, the interval for the x is given minus pi by 2 plus pi by 2. Then the value of this expression tan inverse of 10x upon 4 plus tan inverse of 3 sin 2x upon 5 plus 3 cos 2x. Simplify this children. Tan inverse of 10x upon 4 plus tan inverse. Now trigonometric identities. You know value of sin 2x. Sin 2x is 2 tan x upon 1 plus tan square x. Similarly, identity of cos 2x. You know 1 minus tan square x upon 1 plus tan square x. Simplify this. First of all, simplify this. This we are keeping as it is. Now, how much you will get right here? Simplify this. It becomes 6 tan x and denominator becomes 5 plus 3, 8, 5 minus 3, 2 tan square x. After simplification, you will get this. Further, you can take 2 common, cancel it. So this 2, it becomes 4, it becomes 3. Now you are getting tan inverse x plus tan inverse y. This identity you know. Tan inverse of x plus tan inverse of y. How much this value? Tan inverse x plus y upon 1 minus xy. Condition is here, x into y should be less than 1. This condition is important. So first of all, check the condition. Product of tan x by 4 and 3 tan x upon 4 plus tan square x. This value should remains less than 1. Yes, this is true. So we can use this identity here. So we have to write down. This is the treat as a x. This is a y. So now tan inverse tan x upon 4 plus 3 tan x upon 4 plus tan square x upon 1 minus tan x upon 4 into 3 tan x upon 4 plus tan square x. Further simplify this. Now simplify this bracket. How much you will get? If you take LCM, it becomes 4 tan x plus tan cube x plus 12 tan x divided by, it becomes 16 plus 4 tan square x minus 3 tan square x. Further simplify this. How much you are getting here? You can check, children. It becomes tan cube x plus 16 tan x and divided by, this is 16 plus tan square x. Children, if you take common tan x from the numerator, you will get again 16 plus tan square x. That will be cancelled. So now you are getting this value tan inverse of tan x, and value of x lies between minus pi by 2 plus pi by 2. So tan inverse of tan x we can write as a x. So children, after simplification of this expression you are getting value is x. Now you can check which option is your correct. D option. So D option is the correct options. In this example, an integral solution of the equation tan inverse x plus tan inverse 1 upon y is equal to tan inverse 3 is. Now they have given the options. It means first 2, 7 means 2 is the value of x and 7 is the value of y. So integral solution they have given. So you have to check which option is the correct one. Value of x and value of y should be integers. Now simplify this equation. Tan inverse x plus tan inverse 1 upon y is equal to tan inverse 3. So we can use identity tan inverse x plus tan inverse y. So we are using this identity. We will get x plus 1 upon y upon 1 minus x into 1 upon y. This will be equal to tan inverse 3. Now this is also tan inverse of x is equal to tan inverse of y. It means x and y are same. So we can say x plus 1 upon y upon 1 minus x upon y is also equal to 3. Cross multiply, you will get x plus 1 upon y is equal to 3 minus 3x upon y. Now we have to find out the value of y in terms of x. So 3x upon y plus 1 upon y becomes 3 minus x. Take LCM. So it becomes 3x plus 1 upon 3 minus x is the value of y. Use this relation and find the integral solution. Now children, it is better you have to use the options given here. So in place of x, x value they have given 1, 2, 4 and 5. So in place of x, put 1, 2, 4 and 5 and find out the corresponding value of y. That is better in place of solving this one. Now if you put in place of x 1, numerator becomes 4, denominator becomes 2. 4 upon 2 is 2. 1, 2. Now if you take numerator as a 2, 6 plus 1, 7, or here 1. 7 upon 1 is also 7. If you take x is 4, 12 plus 1, 13 upon 3 minus 4 minus 1. It becomes 13 upon minus 1, that is also integer, minus 13. If you take 5, 15 plus 1, 16, 3 minus 5 minus 2, 16 upon minus 2, minus 8. You are getting integers. It means all. Check value of y. 1, 2, yes, this is correct options. 2, 7, yes, that is also correct options. 4 minus 13, Yes, this is also correct option. 5 minus 8. Yes, it means here all options are correct. So A, B, C, D, all options are correct in this case. In this example, children, see which type question is this? Find the sum up to n terms. First term is here cosec inverse root 10 plus cosec inverse root 50 plus cosec inverse root 170 till its nth term they have given as a cosec inverse root n square plus 1 into n square plus 2n plus 2. Here nth term is given. With the help of nth term, we have to find the its general term after simplification of this, and then we have to add. देखिए चिल्ड्रन इसको कैसे सॉल्व करना है. आई एम सपोजिंग nth term is cosec inverse n square plus 1 into n square plus 2n plus 2 is theta. Then you can say cosec theta will be this value, and squaring do both side, you will get n square plus 1 into n square plus 2n plus 2. Now I am multiplying this. Here 2 I have written as a this n square plus 1, and n square plus 2 I have split as a 1 plus 1 and 2n as it is. Now I am multiplying these two brackets. So it becomes n square plus 1 into n square plus 1, its whole square, plus 2n times n square plus 1 plus 1 into multiplied by n square plus 1. See children here, n square plus 1 ka whole square, 2n into n square plus 1 plus n square. So you can say a square plus b square plus 2ab. So it becomes a plus b whole square. So n square plus n plus 1 whole square. And this one as it is, this is the value of cosec square theta. And you know that children identity, cosec square theta is 1 plus cot square theta. So what is the value of cot square theta? Here 1 will be cancelled. So cot theta you will get n square plus n plus 1. Now with the help of cot theta, you can find the value of tan theta. So tan theta is 1 upon n square plus n plus 1. Now children, you have to try to split this so that we can use identity. Your main aim is to find the nth term as a difference of two terms. Then it becomes easier. So you have to remember. So this type series questions, you have to split this nth term as a difference of two terms. Now how to make the difference here? Children, see here 1 plus n square plus n. If I will take n common, it becomes n plus 1. Do you remember the formula of tan a minus b? So tan a minus b is tan a minus tan b upon 1 plus tan a tan b. So here 1 is you are getting plus tan a into tan b. So here difference should be, it means n plus 1 minus n, you are getting equal to 1. So 1 we have written like this way. So we are getting here theta as tan inverse of n plus 1 minus n upon 1 plus n plus 1 into n. Now children, tan inverse of x minus y upon 1 plus xy, we can write as a tan inverse x minus tan inverse y. So you can say tan inverse of n plus 1 minus tan inverse n. This is the nth term you got. So I am writing here nth term, say Tn is tan inverse n plus 1 minus tan inverse n. This is the nth term. Okay. After simplification of this term, we are getting this one. How will you get the first term? So in place of n, if you write 1, you will get the first term. In place of n, write 2, you will get the second term. Like this way, you have to find out the terms. I am writing here. First term is in place of n, write 1. In place of n, write 2. So this type terms you will get first, second, third. So you can see here like this way. And then you have to add all these terms. if you are adding these terms, first to n terms we have to add. Children, you can see here, this is a positive, next one is a negative. This term will be cancelled by this, and this cancelled by this. Like this way, this term will be cancelled by this, and this term is cancelled by the previous one. So there are two terms are left which are not cancelled. So what is the sum here? Tan inverse n plus 1 minus tan inverse 1. You know, children, the value of tan inverse 1? Pi by 4. Understand this problem? What we have done in this problem? First of all, this nth term we have to try to simplify and express as a difference of two terms. Whenever we can express as a difference of two terms, after that we have to put the values here, n from 1 to n, or if their sum is 1 to infinity, then 1 to infinity, and then add. So automatically cancel the terms. Okay, only first and last term will be remaining. So sum is this much. Children, see in this example, in a triangle ABC, the value of angle A is tan inverse 2, value of angle B is tan inverse 3. Then we have to find out the value of angle C. Options they have mentioned here: pi by 3, pi by 4, pi by 6, and none of these. Children, you know, in a triangle, what is the sum of three angles? 180 degree or pi radian. Value of A they have given tan inverse 2. Value of B they have given tan inverse 3. If you add and subtract from pi, you will get the value of C. How much their addition? Tan inverse 2 plus tan inverse 3. You know the identities? Tan inverse 2 plus tan inverse 3, we can write tan inverse of 2 plus 3 upon 1 minus 2 into 3. But this value is more than 1. So whenever the product is more than 1, we have to take here pi plus. This is the identity you have to remember. In the module we have given this. According to the condition, if product of xy is more than 1, then you have to write down the identity pi plus tan inverse of x plus y upon 1 minus xy. Now children, this pi and this pi will be cancelled. Its value becomes tan inverse 5 upon 1 minus 6 minus 5. So this value tan inverse of minus 1 minus, you can write outside, to tan inverse of 1. So what is the value of C? That is tan inverse 1, and you know tan inverse 1 is pi by 4. So what is the value of angle C? Pi by 4. Answer is B, pi by 4. Children, I have given the questions in the modules. You have to do practice from the modules. We will meet in the next lecture now.